Okay, so I'm going to start off by doing number 2 from Daddel's quiz. So there's a whole bunch of words there, but the 2 things that we've been asked to do is to find the velocity and the height. So then if I were working backwards, it says, assume that the derivative of the position or height function is the velocity. So assume that the velocity is equal to the derivative of the height, and that the velocity is the derivative of, that the derivative of the velocity is the acceleration. So this is kind of where we have to start. So when I looked at this, I said, okay, I know that dv dt is supposed to be the acceleration, and we've been given that that's negative 32. Let me go ahead and pin my video really quick. Sorry. Okay. So we've been given that that's negative 32. So now I need to find the antiderivative to get back to the velocity. Since negative 32 is a constant, when I find the antiderivative, that would just be negative 32. And normally we might think of that as negative 32x. But typically when we're talking about position, velocity, acceleration, the variable that we're using is t instead. I think you would have gotten all the points correct if you wrote an x or maybe 1 point taken off, but it would be better to write that as negative 32t. Because we're taking an antiderivative, we also need that plus c. And then I'm going to go ahead and find what that c is right away, because in the statement of the problem, we're told that it's dropped from rest. And that phrase from rest means that the velocity is 0 when t equals 0. So if I plug those in right now, I'm going to get 0 is equal to negative 32 times 0 plus a constant, which means this constant is 0. So our velocity function is negative 32t. And we should probably include units here. And since our units for acceleration were feet per second squared, that's going to make our units for velocity feet per second. So we did the velocity. Now the next part, we were also asked to find the height. So using this relationship that the derivative of our height function is equal to the velocity, and now we know our velocity function is negative 32t. To get our height, we're taking an antiderivative. So if this is negative 32t, there's an invisible exponent of 1. So using our derivative rules, I'm going to add 1 to the exponent, and then divide by the new exponent. And then once again, we need to remember to add that plus a constant. So now I'm going to go back to the problem, and it also tells us that it was dropped from a height of 128 feet, meaning the height is 128 at time t equals 0. So plugging that in, I've got 128 is equal to 0 plus a constant, which means our constant is 128. So my final answer for the height as a function of time would look like, I'm going to go ahead and simplify this. Negative 32 over 2 would be negative 16 t squared, and then plus the 128. And again, I'm going to include units on here just to make sure that we've got it.